Here in this section, we have volumes using cross-sections. The first part is definition. The volume of a solid integrable cross-sectional area AX from x equal to a to x equal to b is the integral of a from a to b. So volume is equal to integral of ax times dx. This is for when x is from a to b. So what we have for volume, volume is equal to area times height, or we can write a for area multiplied by h for height. Here I have steps how to calculate the volume of a solid. So first step is sketch the solid in the typical cross section. Step 2, find the formula for a of x, the area of typical cross section. Find limits of integration, and finally integrate a of x to find the volume. Example: a pyramid 3 meter height has a square base that is 3 meter on the side. The cross section of the pyramid perpendicular to the altitude x in meter down from the vertex is a square x in meters on the side. Find the volume of the pyramid. So here is what we have for pyramid, and this one above x-axis. So based on what we have here in this pyramid, we have this square. Here inside we can move this. If I move that one, we're gonna have this square here. So this is what we have for step 1. We sketch, so we draw the pyramid with its altitude along the x-axis and its vertex at the origin, and that includes a typical cross section. Now step 2, we have to find area of what we have for this part, this square. So find the area of what we have here for the square, that is x times x, so it's x squared. So a formula for ax, the cross section at x is square of x, which is in meters on the side, so its area is ax is equal to x squared. Now step 3, limit of integration. So here on this part it says a pyramid 3 meters high. So the square line on the planes from x equal to 0 to x equal to 3. So what we have is x equal to 0 to x equal to 3. Now step 4, integrate to find the volume. So volume is equal to integral from 0 to 3 of f of a of x times dx. So this is equal to integral 0, 3. Here our ax, or area of this square, is x squared times dx, and this is equal to, so here we have x squared, adding 1 to this power is x cubed divided by 3. This is from 0 to 3. So substitute this 3 here instead of x. We have 3 cubed divided by 3, so that is 27 divided by 3 minus, use that 0 instead of x. So we have 0 cubed divided by 3, so that is 0. What we have here is 27 divided by 3 minus 0, and that is 27 divided by 3, so the answer is 9. And this is volume, so this is 9 meter cube. Now here on this part we have disk method. So solids of revolution. The disk method, the solid generated by rotating or revolving a planar region about an axis in its plane is called the solid of revolution. To find the volume of a solid like the one that we have here on this part. So this figure, we first observe that the cross-sectional area A of x is the area of a disk of radius Rx. So here on this part, radius is what we have for Rx, and that is equal to square root of x, where Rx is the distance from the axis of revolution to the planar region's boundary. The area is equal to pi r squared, or pi radius squared. So based on that, what we have for volume by disk for rotation of the x-axis is equal to integral when x is from a to x equal to b, a of x times dx. So this integral is from a to b, and our a of x based on what we had here on top is equal to pi r squared times dx, or pi times rx squared times dx. So this method for calculating the volume of solid revolution is often called disk method. Now, example based on the figure that we had here, so figure 6.8, which is this figure about y equal to square root of x. So the region between the curve y equal to square root of x when x is between 0, 4 inclusive, and the x-axis is revolved about the x-axis to generate a solid. Find its volume. So based on what we have, import A over region y equal to square root of x. This one revolving above x-axis, and based on that, what we have here. So this is this line here, that is after trying to revolve above x-axis, you're going to create a disk. This one, and here based on that we can find volume. So we draw figures showing the region and typical radius and the generated solid. So volume is equal to integral a to b pi times rx squared times dx, based on what we have here. Integral when we have on x, so this is based on x. This one revolving above x-axis, so, and this is starting from 0 to 4. And here we have this given. So pi times, when we have for radius, that is rx equal to square root of x. So here we have square root of x squared times dx. And this is equal to pi times integral square root of x squared, that is x, and this is equal to pi. So here we have power is 1, we should add 1, so 1 plus 1 here is x squared divided by 2, and this is from 0 to 4. Now using 4 instead for x, so we have pi times 4 squared divided by 2, and here we have 0, so it's minus pi times 0 squared divided by 2. So this part here, this one is 0. So what that means, our answer is based on what is here. So here we have pi times 4 squared. 4 squared is 16. 16 divided by 2 is 8. 8 times pi. So the answer is 8 pi. Example, find the volume of the solid generated by revolving the shaded region above the x-axis. So what we have here on this for the solid is a cone with its vertex on the x-axis. A cross-section of the solid is a disk perpendicular to x-axis with radius, the segment from the x-axis to the line based on what we have here for x plus 5y equal to 20. And the volume is integral from a to b. So in this case, 0 to b, and that is for pi times rx squared times dx. So here is from 0 to 5. And this one revolving above x, we're going to have something like this. So having a circle or a disk. So volume is equal to integral from 0 to 5, because this is above x-axis, we have to work based on what we have on x-axis, and this is 0 to 5. And it's pi times rx squared. So first we have to find rx based on this line. So what is given, we have 4x plus 5y equal to 20, solving for y. So 5y is equal to 20 minus 4x, isolate y is equal to 20 minus 4x divided by 5. So that is our rx. That is what we have here on this part. For our radius, because that's not revolving above x-axis. And this is what we have for our radius or rx. So rx is 20 minus 4x divided by 5 squared times dx. So now what I did here on this part, I factor out 4, so 20 minus 4x, what we have in common is 4, and that is 4 times 5 minus x. And then here we have 4, and using that power, so this is 4 squared, so it's 16 times pi times, we can simplify this part. 5 divided by 5 is 1, and we have x divided by 5, so this is 1 minus x over 5 squared. So now this part is equal to what I have here, 1 minus x divided by 5 squared, that is equal to 1 minus 2x over 5 plus x squared over 25. Now finding integral, we have 16 pi times here is 1, so integral is x, and for this part 2x divided by 5, power is 1, so adding 1, that is 2x squared divided by 2 times 5. We can simplify, so 2 divided by 2, and what's left here is x squared divided by 5. So here I have x squared divided by 5. And then for this part, we have x squared over 25. So 2 plus 1 divided by 3 times 25. So it's x cubed divided by 75. And this is from 0 to 5. So instead of x, we have to use 5. And we have to use 0. We don't need to write 0 because writing 0, we're going to have 0 times 16 pi. So that will be 0. So I used 5 instead of x, and that is equal to 16 pi times 5 minus 5 squared divided by 5 plus 5 cubed divided by 75. And again, if you want to use 0, you're going to have minus 16 pi times 0 minus 0 squared divided by 5 plus 0 cubed divided by 75, and that part is 0. So we don't need to write. Now simplify, so this is equal to 16 pi times, here we should have same denominator, and that is, so I use 75 here, and subtracting, adding all that we have here on top. So simplify, the answer will be 80 pi divided by 3, and that is in cubic units. So this is our final answer. Another example, find the volume of the solid generated by revolving the shaded region above the x-axis. So what we have here on this part, y is equal to 8 sine x times cosine x. So what we have here, the solid generated by rotating or revolving a planar region above an axis, and its plane is called this solid of revolution. So we need to find a volume of this solid. So first, note that the cross-sectional area is the area of a disk of radius rx, and here our radius is 8 sine x cosine x. So to find volume, that is equal to, so from A to B, area times dx. So what we have here, this is equal to integral from A to B, area is pi times radius square times dx. In this case, radius or rx is equal to 8 sine x cosine x, and so this one revolving about x-axis, but we have an x-axis, this is from 0 to pi over 2. So A is 0, B is pi over 2. So our volume is integral from 0 to pi over 2, pi times our Rx is 8 sine x cosine x square dx, and this is equal to the integral 8 squared is 64 times p sine square cosine square dx. Now here, instead of sine square, I used 1 minus cosine 2x divided by 2, and instead of cosine square, I used 1 plus cosine 2x divided by 2. So now we have to simplify. Here in the denominator we have 2, so 2 times 2, we have 1/4. So integral 64 pi times 1/4 times 1 minus cosine 2x times 1 plus cosine 2x times dx, and that is equal to integral 16 pi times, so here we have 64 divided by 4, that is 16. So 16 pi times 1 minus cosine squared 2x times dx. So what we have here, if you multiply for that part, we have 1 minus cosine squared times 2x, and that is equal to integral 16 pi times 1 minus, instead of cosine squared 2x, I use 1 plus cosine 4x divided by 2 times dx. And again, here I simplify, so we have 1 minus for this part. This one 1 divided by 2. So here we have this negative. So negative multiplied by all these that we have here. So negative times 1, negative times cosine 4x, and then divide by 2. So this is what we have here after simplifying. And that part is equal to what we have here on the right side. So it's integral 16 pi times 1 minus 1 over 2, that is equal to 1 over 2 that I have here, minus 1 over 2 times cosine 4x times dx. And here we have 16 divided by 2, so that is 8 pi integral. So we divided by 2, that means what's left here in parentheses, we have 1 minus cosine 4x times dx. So finding integral, we have 8 pi times, here we have 1, so that is x. Now cosine 4x, here we have negative 1 over 4 sine 4x. And this is from 0 to pi over 2, so instead of x, now we have to use pi over 2 and then subtract and use 0 instead of x. So instead of x, here we have pi over 2, here we have pi over 2, and then subtracting, use 0 instead for x. So the answer that we have here is 8 pi times pi over 2 minus this part 0 minus 0 minus what we have here is 0. Now multiply, so the final answer is 4 pi squared, and that is cubic units. So this is our final answer, 4 pi squared. That is our volume. Now on this part we have volume by disk for rotation above the y-axis. So instead of x-axis, now here on this part we have y-axis. So volume is equal to integral from C to D, and that is for this area A based on what we have for y times dy. So that is equal to integral C to D pi times ry, which is our radius. And again, this is revolving about y-axis, not x-axis. That's why here I have ry. So ry squared dy. So r is just for rotation. Example, find the volume of the solid generated by revolving the region enclosed by x equal to square root of 50 times y squared, x equal to 0, y equal to negative 2, y equal to 2 about y-axis. So here we have a graph for this function x equal to square root of 50 times y squared, and cross-section of the solid is a disk perpendicular to the y-axis with radius whose length is segment from the y-axis to the curve x equal to square root of 50 times y squared. So the region rotated about the y-axis to generate the solid is the shaded region in this color that I have here. It's in orange. So now to find the volume of solid generated by revolving a region between y-axis and our curve x equal to So this one is ry. So that is ry. So ry is equal to square root of 50 times y squared. And this is from -2. Our integral is from -2 to +2, because here it says y equal to -2, y equal to +2. So volume integral -2 +2 pi ry square times dy, and that is equal to integral pi times 50 y to the 4th power, because here I used this power here. So I have square root of 50 to the 2nd power, y squared to the 2nd power, that is equal to 50 y to the 4th power times dy, and that is equal to pi times 50 times here 4 plus 1 is 5 divided by 5 to find integral, and we have to use this is from -2 to +2. So using first I simplify, so 50 divided by 5 is 10. So what I have here is pi times 10 times y to the 5th power, and now using 2 for y and -2 for y. So and that is equal to pi times 10 times, instead of y use +2, 2 to the 5th power minus pi times 10 times -2 to the 5th power, so -2 instead of y. And what we have here is 2 to the 5th power, that is 32 times 10 is 320 times pi. Then we have -2 to the 5th power is equal to -32. -32 times 10 times negative times pi is equal to positive 320 pi. And adding these two numbers, we have 640. So it's 320 plus 320 is 640 times pi. So this is our final answer for this part. This is our volume. So the volume of the solid is 640 pi cubic units. Example, find the volume of the solid generated by revolving the region between the y-axis and the curve x equal to 2 divided by y between 1, 4 inclusive above the y-axis. So here we have this part A is our region, and part B the part of the solid of revolution, which is about this one revolving above the y-axis. So finding volume, this is equal to integral. This is above y-axis, so here we have from 1 to 4 pi times ry squared, and our ry is 2 divided by y. So what we have here, x equal to 2 divided by y. This one is ry squared times dy. So this is equal to pi times integral. We have 2 squared divided by y squared times dy. That is equal to, we have 4 times pi, and here integral for 1 over y squared, here is negative 1 over y, and this is from 1 to 4 Now we have to use 4 instead for y and 1 for y. So we have this is equal to 4 pi times negative 1 over 4 minus 4 pi times negative 1 over 1. So simplify 4 pi divided by negative 4. Here we have negative pi plus here we have negative 1 over 1. That is negative 1 times negative 4 pi. It's 4 positive 4 pi. So negative pi plus 4 pi, the final answer is positive 3 pi. Now in this part we have solids of revolution, the Washer method. If the region we revolve to generate a solid doesn't border on or cross the axis of revolution, then the solid has a hole in it. So here we have this figure is based on y equal to uppercase R and y equal to lowercase r, and that's one revolving above x-axis. So the cross sections perpendicular to the axis of revolution are washers instead of disk. So that's why we have instead of disk we have washer. The dimensions of a typical washer are outer radius and inner radius. So for outer radius we use uppercase R, and for inner radius we use lowercase r. So the washer area and the area of circle of radius Rx minus the area of circle radius Rx. So what we have for outer radius and what we have for inner radius. So area is equal to pi times outer radius squared minus pi times inner radius squared. That is equal to pi. So and here so it is just same thing, and that is equal to pi times Rx squared minus Rx squared. So we factor out pi on this part. Now volume by washes for rotation of the x-axis. Volume is equal to integral a to b ax times dx, and our area based on what we had here is pi times, so just this part, pi times outer radius squared minus inner radius squared times dx. So here we have washer instead of disk. Because there's a hole. Now example, find the volumes of solid generated by revolving the regions bounded by the lines and curves y equal to secant x, y equal to tangent x, x equal to 0, x equal to 1 about x-axis. So this is what we have based on y equal to secant x, y equal to tangent x, and x from 0 to 1. So our outer radius is this part, and inner radius is what we have for tangent. So this one is Rx, and this one, so that is outer radius, and this is inner radius. Now finding volume, integral, this is from 0 to 1, pi times outer radius squared minus inner radius squared times dx. So that is equal to pi times integral 0 to 1. Outer radius is secant x, and here we have square, so it's secant squared, minus inner radius is tangent, and we have square, so it's tangent square times dx. So this is equal to pi times integral secant square minus tangent square is equal to 1 times dx. Finding integral, this is equal to pi times x, and this is from 0 to 1. So we have pi times 1 minus pi times 0. So the answer is pi times 1, it is pi. So our final answer for this part, volume is equal to pi. Other example, the region enclosed by the triangle with vertices 0, 1, 1, 0, and 1, 1. Find the volume of a solid generated by revolving each region above the y-axis. So here we have 0, 1. There's this one here. Then we have 1, 0. And we have 1, 1. So we have this triangle. And this revolving above y-axis. So here this line is y equal to 1 minus x. And what we have here, outer radius is equal to 1. And inner radius is equal to 1 minus y, because we have to solve for x. What we have here is y equal to 1 minus x. That means x is equal to 1 minus y. So this is what we have for inner radius or y. So again, this revolving above y-axis, and here is what we have, x equal to 1, that is outer radius, so our y equal to 1. And here on this part, finding what we have for x is equal to 1 minus y, and that is inner radius. Now finding volume. Volume is equal to, here this is from 0 to 1. So here we have 0 and this is 1. Pi times ry squared minus, now this one for inner radius, square times dy. So times dy, because this one is revolving above y-axis. And then this is equal to pi times integral times what we have for outer is 1 minus for inner we have 1 minus y square. So here 1 square, is equal to 1, so I didn't write 1 square, times dy. This is equal to pi integral. We have to find 1 minus y squared. So this is equal to 1 minus, here we have 1 minus 2y plus y squared times dy. And this is equal to pi integral 0 to 1. 1 minus 1, that part 0. Then we have negative times and negative 2y, negative times positive y squared. So here we have 2y minus y squared times dy. Now finding integral, we have pi, we have 2y, so we're going to have 1 plus 1 for power divided by 2. So 2y squared divided by 2. Simplify, that part is y squared. So I'm going to write all steps here. We have 2y squared divided by 2 minus y cubed divided by 3. This is from 0 to 1. So that is equal to pi y squared minus y cubed divided by 3 from 0 to 1. Now we have to use 1 for y and 0 for y. So we have pi times 1 squared minus 1 cubed divided by 3. So that is pi times 1 minus 1 over 3 minus, I didn't write that part, so because that part is 0, pi times 0 squared minus 0 cubed divided by 3. So that part is 0. That means what we have here is just this part, and simplify, the answer is equal to 2 pi over 3. So this is our final answer for our volume.